Welcome back. This is a video that will discuss when two secants meet outside of a circle, but not for angles, but their lengths of the segments. We'll begin with the proof, given that circle O, secants PB and PD, chords AB and BC. So we want to prove first the proportion, that PB to PD is equal to PC to PA. Well, when we prove proportions, normally what we're trying to do is we're trying to come up with the proof that two triangles are similar to each other. Now, which triangles are we talking about? Well, let's take a look. Well, we have line segment PB. So here we have line segment PB to line segment PD. So that would be this segment here. And the matching PB to in this case PC, so it would be this measurement here. And then PA will match up with PD. So in this case, this triangle here. So it looks like in this case, we're looking to prove triangle PBC is similar to triangle PDA. So that's our goal. Okay, so we're going to prove those triangles similar. All right, so in this proof, we're first going to be looking at, well, the givens, so statements and reasons. Okay, so we have a givens. All right. And so I'm going to make this a full screen so you see everything else. So it's going to be a little tinier. All right. So here we go. All right, so our first step to prove those triangles similar, we're going to look at, in this case, angle P, congruent angle P, reflexive property, or an angle is congruent to itself. And so here, we're going to show that this angle is congruent to itself. All right, and it makes sense because angle P is an angle of both triangles, PBC and PDA. Okay, our second step would be try to look for the second angle. Remember, to prove triangles similar, one of the popular methods to prove two angles of one triangle are congruent to corresponding two angles of another. So we have one pair of angles. Our second pair of angles would be angle B is congruent to angle D. Now, why is that? Well, in this case, both angle B and angle D are inscribed angles. And so in a circle, inscribed angle is equal to 1/2 the measure of the intercept arc. And here, for this angle B, arc AC is going to be the arc that's going to be the arc intercepted. But it's the same arc for angle ADC. They're both inscribed angles. And if two inscribed angles of a circle intersect the same arc, then they are congruent. So mark those off. And now we have two triangles similar, because we know in this case, if we'll say in this case, triangle PBC is similar to triangle PDA. All right, and then, you know what, in case you guys would like to make it a little bigger, because at this point, so you see the diagram here, we can move it down a little bit here. We'll see in this case, triangle PBC is similar to triangle PDA. If two angles in one triangle are congruent to the corresponding two angles of another triangle, then they are similar to each other. So we have in this case the triangles being similar. And now we're proving our next step in this case, the first part A, that PB to PD is equal to PC to PA. Now, some of you normally will see this proportion written in this manner, that PB over PD equals PC over PA, and that's the same exact thing. Okay, just in this case, both two ratios are equal to each other, so proportion, and corresponding sides of similar triangles are in proportion to each other. Okay, so that's not not CP/CTC, that corresponding parts of common triangles congruent. This is the one that we use for similar triangles. Corresponding sides of similar triangles are in proportion to each other. And now, because we have proportion, we can say that in this case, that PB times PA is equal to PD times PC. In a proportion, the product of the means equal to the product of extremes. And now, again, some people learn proofs when they do this. Sometimes they'll use they'll actually say cross multiply. I'm going to explain things. I like a little old-fashioned type thing. So all these things are written out, and so you guys can see reasons why. And not say one way is better than the other. I think the main thing is understand the concept behind it, and of course, to be able to explain where things come from. Okay, so in general, so now again, for seasonal, oops. So PB times PA equals PD times PC. And so we see in this case that we do end up getting this result. And this is when two secants intersect. So let's take a look. Two secants intersect outside a circle. Then what happens is the product of the measures of the one secant and external segment is equal to the product of the measures of the other secant and external segment. Meaning in this case, like we said before, the whole secant measurement, so all of PB times its outside part, which is PA, is equal to the whole measurement of PD times the outside part, which is PC, the external segment. So the whole times the outside part equals the whole times the outside part. Now let's take a look at an example. We're going to have secants PQR and PST are drawn to circle O. If PR equals 15 and PQ equals 6 and PT is 10, find PS. All right, well, okay, so the whole segment we know, the whole segment is PR, which is 15. And the outside part, external segment, is going to be PQ, which is 6. All right, so it's the whole segment PR times the outside part, which is PQ, is equal to the whole segment, the secant segment, in this case PT, and PT is 10. So PT times the outside part, which is PS, which we don't know. So we can call it X if we want to. And so now we'll fill in the information. We'll set, again, I like writing everything out so that I know what equation I'm going to be using or finding in this case. So I have 15 times 6 is equal to 10 times X. Well, 15 times 6 is 90. And if 10X equals 90, we divide both sides by 10. X equals 9. Therefore, we have, in this case, the measure of PS is equal to 9. Well, that's not so bad. Oh, they get more difficult, though. So let's take a look at a more challenging problem, right? So, but the key thing is this. The whole segment times the outside part is equal to the whole segment times the outside part. And so from point P, secants PAB and PCD are drawn to a circle. If PA equals 2, AB equals 4, CD equals 3, find the length of secant segment PD to the nearest tenth. Okay, so nearest tenth usually means that there could be a situation where the number will not be nice. Maybe a radical involved and have to simplify that. No, so we'll see. Let's take a look. Well, we know the whole segment. The whole segment is PB. It's a whole segment times the outside part, which is PA. So we're first going to write out the pieces we need, okay? Is equal to the whole segment, which in this case is PD, times the outside part, which is PC. Again, notice we write this whole thing out instead of trying to plug numbers right away. The issue is, well, why not? What's wrong with that? Well, let's take a look. So we have here PA is 2. That's fine. And AB is 4. Except that would mean that PB is neither 4 or 2. It's going to be 6. And that's a trap the students kind of get caught up in, like, oh, well, you know, what do I, you know, I don't know how to find PB. Oh, yeah, you do. You can add the two segments together. So we have 6 times 2. All right, so that's that part there. Now, PD, we don't know. We do know CD is going to be 3. And we're trying to find, in this case, PD. Well, we don't know what PD is. Because, honestly, we don't know what PC is. Let's call PC X. So PC is X. That would mean that PD has to be the sum of the two pieces, X plus 3. Again, we're adding together. Again, be very careful. A lot of times, some students will accidentally multiply the 3 and the x, make it 3x. It's really x plus 3. So PD is x plus 3. And in this case, PC is our x value. So now we're going to multiply, all right? So this is a little more complicated. So instead of trying to jam numbers together, you really want to write out what the segment measurements are first and then fill into your formula, because this will be a lot easier and save you a tremendous amount of grief, because instead of saying, well, how come I got the answer wrong? I used the formula, I plugged the numbers in. Oh, you maybe didn't plug in the right numbers, and you didn't find the right segment measurements. So please remember, ladies and gentlemen, math is not about just plugging numbers in. It's about analyzing information, coming up with a way to show or find the answer, and then of course solving. So 6 times 2 is 12. X times x plus 3, we're going to use our distributive property and get x squared plus 3x. Now at this point, we'd probably say, okay, well, normally it's quadratic equation, so I would normally set the equation equal to 0, so subtracting 12 on both sides. 0 is equal to x squared plus 3x minus 12. Okay, so normally when I factor, I try to find two numbers that multiply 12 and subtract a 3. And then two numbers multiply 12, 1 and 12, and 2 and 6, and 3 and 4. And none of those pairs of numbers actually give me a value that subtracts the 3. So we have to use quadratic formula, all right? And so now for quadratic formula, we're going to do the following. Quadratic formula is going to be x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, some of you guys might have learned this by singing the song, Pop Goes the Weasel. I'm not that type of teacher. Sorry about that. I know Mr. Bobo is, so, But anyway, how you learn is the way you learn, okay? So, no criticism. Now, what are a, b, and c? Well, in our quadratic equation, we have our coefficients a, b, and c are the coefficients for x squared, x, a linear term, and a constant. And so here, our a value is equal to 1, our b value is equal to 3, and our c value equals to negative 12. So now we're going to plug this into our formula here, and so we're going to have x is equal to negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 12 all over 2 times 1. And so we end up getting x is equal to negative 3 plus or minus the square root of, well, 4 times negative 12 is 48. And 3 squared is 9. So 48 plus 9 is 57. All over 2. So now we're going to find the two values, okay? And so we have, in this case, x is equal to negative 3 plus square root of 57 over 2. X equals to negative 3 minus square root of 57 over 2. Now, this one's going to be negative value. So we look at a measurement, it can't be this measurement here. So, all right? So we'll take our calculator. Okay, so our calculator, we're going to type in negative 3. So negative 3 plus, now square root of 57. And I'm going to hit enter. Now I'm going to divide this by 2. And so here we're going to get a value of 2.9949. Now, why do I do this first instead of typing the whole thing in? Well, the major mistake, oh wait, answer. Hold on a second there. Where'd the answer come from? Let's try this again. Sorry, ladies and gentlemen. Negative 3. Oh, and I'm not 0.3. Huh. It's not going so great. Okay, hang on a second. Here's negative 3. Negative 3 plus the square root of 57. 57, actually. 57. Enter. Now divide that by 2. There you go. That's what we're looking for. Again, so why do I do this 2 steps? Because if I sometimes do type the whole thing in, I might accidentally divide only the square root of 57 by 2 and not negative 3. And so here, we're going to get an answer of 2.27. So x equals 2.27. And so that's what we're looking for, I believe. Let's take a look. And so we're looking for the measure of PD. And PD, nope. We're looking for 3 times. So PD is equal to 5 0.3. That's our answer we're looking for. Okay, ladies and gentlemen, hope it's helpful. Take care.